All right, so today we are writing addition and subtraction expressions. Now that word expression, just keep in mind all that means is it is a math problem. So yeah, we're writing addition and subtraction math problems out here. So we're going to ignore that first part, not worry about your diagram there. Go back to your basics. We'll fill this in just because, well, it's straightforward there. How are you going to show 5 plus 3? Well, we're going to put down a 5, and then an addition sign, and then a 3. Yay! Now, we're going to go back to what it said up here. It did show 3 plus 5, so we will put that down as well. Because the question did ask us, are these two expressions equivalent? And you should be thinking, yeah, we know 3 plus 5 is 8 and 5 plus 3 is 8, but you're thinking, no, that's not the real reason why. You're thinking about your good friend, the commutative property. So are they equivalent? Yes, they are equivalent, just meaning equal to. So now we're going to show how we show a number increased by 2. The big thing here is a number. We don't know what that number is. So what do we end up using for that? Well, we use a variable. So we use a letter. Typically, X is our most popular one. Increased means to add. So X plus 2. And there we go. Don't worry about proving it using a model. All right, I'm not worried about that particular portion right now. So let's keep moving forward. Write an expression. Remember, an expression is a math problem to show the sum. All right, so here's another word. So we're going very vocabulary here again. Sum. The sum is the answer to an addition problem. So it does mean to add, and that's important there. Sum does mean to add, but it's something more important because it also means get ready, all right, to use parentheses. We're going to see that moving forward, but since it just says the sum of m and k, yeah, m plus k, voila, that's it. Which property can be used in examples 1 through 3 to show, and we used that phrase already. What is it? What is it? What? Yes, commutative property. And remember, the commutative property of addition lets you flip the order around that you're looking at. Oops, sorry about that. Let's see right there. Here we go. So how can we show 10 minus 6? Well, I'm not worried about a bar diagram. Let's go to your expression. Remember, your expression is, yes, math problem. So 10 minus 6. Can we use 6 minus 10? No, we can't. It's not the same thing. So we talked about this before. Is subtraction commutative? No, it's not. All we have is our addition and our multiplication that is commutative. Let me scroll back up just a little bit. That's more than a little bit. Example number 5, how can we write an expression, so a math problem, to show 3 less than a number? Now, less than, first of all, which operation is that? Less than does mean to subtract, but wait, there's more, all right? It also means that we need to flip the order as well. So when it says 3 less than a number, yes, it is going to be, and we're going to get rid of that there. Yes, it does mean to subtract, but we got to flip the order. The 3 came first, which means it actually needs to come second. The a number, which came second, actually needs to come first, so it's actually x minus 3. It's just the English language that changes the order around. So let's see what we've got here. How would we write an expression to show the number c being subtracted from the sum of a and b? All right, so first of all, we start with the sum. And this is the reason why we want to, is because sum, as we talked about, it uses the parentheses. Because remember, it's the answer to an addition problem. You've got to get the answer first. So get ready to always use parentheses. It's better to have them there and not need them than to not use them at all. So start by writing the expression for the sum of a and b. So we're going to add a and b together, but then c being subtracted from. Okay, so remember how less than made us flip the order? Well, subtracted from shows that because we've got to do our addition problem. So we're going to wrap it in parentheses, and then we're going to, from that, we're going to subtract c away. So subtracted from also means to flip the order. So those are two that we really got to end up watching for. You're not scared of the next problem, are you? No. Okay. So write an expression to show the number c minus the sum of a and b. So remember, sum, answer to an addition problem, all right, needs to get wrapped in parentheses and then a number c minus. Now, the c and then the minus came first, so it will go first. So everything's always going to read left to right, except for a few special words. And we've seen two of them now. Less than is one of them, and subtracted from, that's another one as well. So why are the parentheses necessary in this example and not the others? Well, because of our good friend, order of operations. And the big thing here is, here we want to do the addition first, okay, and then we want to end up doing the subtraction. The previous problem, it was already built in. We were going to work left to right. We were going to do the a plus b first anyway because we're going left to right, but the parentheses are just there to reinforce that. So don't read into those too much. Everything reads from left to right except for our special words. So we can check in there, replace the variables there, and this is if we plug it in. The main thing is subtraction commutative? And no, it's not. So we can't flip the order around with our subtraction problems that we are dealing with. We can't do it second in this problem because here we would do the addition first and then the subtraction. And here we want to do the subtraction and then the addition. It doesn't make sense. All right, so let's go through the next one there. Write an expression to show the sum of 7 and 1 5/10. Go ahead, put it down. Put it down. Expression, a math problem. Sum, answer to an addition problem. So we're just going to add them up there. All right. Could you wrap it in parentheses because sum means use parentheses? You could. No big deal. But again, when it's the only one that's there, no need to end up putting that in there. Here they want us to write two expressions to show W increased by 4. So remember, we always read from left to right. So W, let's increase. So let's add, and then by 4. They want another one. It's not necessary, but the main thing is this is why can we do this? Why? Because of? Yes, the commutative property. Our commutative property allows us to do that. So we're not going to worry about drawing models here. Question 3, write an expression to show the sum of A, B, and C. Well, sum, again, answer to an addition problem. Because it's all addition, who cares about parentheses? We're just going to go left to right. So A plus B plus C shows over. Could you wrap it all in parentheses? Certainly could. But when it's the only thing that's there, it's not necessary. Problem 4, write an expression and a model showing 3 less than p. We're not worried about any of the models here. All right, if you notice that, we're just worried about writing out the expressions. Less than, it does mean to subtract. But what's so special about less than? Yes, it does mean that we do need to flip our order around. So the variable p needs to come first here because it came second there. And then the number 3 needs to come second because originally it came first. Let's look at 5. Write an expression to show the difference. Difference is the word, this is our answer to a subtraction problem. All right. Difference and sum are very similar because they imply parentheses. Ooh, kind of bad parentheses. They're kind of a letter C there. Let's kind of clean that up a little bit. So we've got to make sure we use parentheses with these guys. Now, again, when it's the only thing that's there, it's no really need to. I mean, we could. We're okay there. Like I said, it's better to have them and not have them. So sum needs parentheses. Difference needs parentheses as well, too. Let's see what we got there. Write an expression to show 4 less than the sum of G and 5. Oh, my goodness. This kind of does everything here. Take a moment to try it real quick. Try it real quick. So less than does mean to subtract. So we are going to have to use the subtraction sign. but it also means to flip the order around. So since the 4 came first, it's going to need to come second. Sum means to add. So we're going to add G and 5 together, but who has to make an appearance? Yeah, we'd like our parentheses to make an appearance because sum is the answer to an addition problem. Now, do we need the parentheses here though? Technically no, because we're going to go left to right anyway. But again, safety net, let's make sure we put that in there. Let's look at 7. Write an expression to show 4 decreased by the sum of G and 5. Decreased by. So this doesn't have any of our special words that go along with it. So there's a 4. There's a 4. Decreased, which means to subtract. And then the sum, which does mean to add. But what's missing? Oh, you're not cuckoo if you didn't put your parentheses in. Yeah, the parentheses. If you said parentheses, you're good there. You're good. Because remember, sum answer to an addition problem. And this is going to force us to do the addition first and then to do our subtraction. So should exercises 6 and 7 have different expressions? Do we have different expressions? We certainly do. Yes, 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 yes. But why should they? And it's the whole idea that subtraction is not, it's not what? It's not commutative. Oh, we got an extra letters in there. Extra for my M's there. Yeah, it's not commutative. Remember, we can't flip the order around.
Game over.